أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. In this session, we are going to talk about correlation coefficient. Correlation coefficient describes the direction and strength of linear relationship. Now, previously we have visualized between two quantitative variables using scatter plots. We have also described the overall pattern of the relationship by considering its direction, form, and strength. We noted that it is difficult to assess the strength of relationship just by looking at the scatter plot. Now, in this section, we develop a numerical measure to assess the strength of this relationship or the relationship between two variables. We only focus on relationships that have linear form. Now, linear forms are quite common and relatively simple to detect. More important, we have a numerical measure that can assess the strength of the linear relationship. Now, the measure of strength we are about to study can be used only for linear relationships. And that measure of strength is R, that is the correlation coefficient. And this is a numeric expression that can measure the strength and direction of linear relationship between two quantitative variables. By direction, we mean that this correlation coefficient will have a sign with it. Now, if it has a negative sign, then the direction is opposite. That is, increase in one variable leads to a decrease in the other. Now, the negative sign would mean that there is an inverse relationship between the two quantitative variables. Now, how do we interpret that correlation coefficient of R? Now, there are no strict guidelines for interpreting the strength of correlation coefficient, that is R. However, some researchers have proposed the following guidelines. So, what is the first guideline? A correlation coefficient of 0.1 or less is considered very weak. A correlation coefficient of 0.1 to 0.3 is considered weak. Now, the correlation coefficient ranges between 0 to 1. And on either sides, that is, if it's closer to 0, it is weak, and the closer it is to 1, it is strong. Now, it can be negative and it can be positive. A correlation coefficient of 0.3 to 0.5 is considered moderate. Now, it could be plus 3, that is a positive moderate or positively moderating relationship. Now, it could be minus 0.3 or minus 0.5, or it could be plus 0.3 or plus 0.5. Now, minus here would mean there is an inverse relationship between the two variables. Plus obviously means a positive relationship. Correlation coefficient between 0.5 to 0.7 is considered strong. And finally, anything over 0.7 is considered very strong. Now, obviously, a correlation coefficient over 0.85 would mean there are issues of multicollinearity. That means that both these constructs whose relationship is being assessed are actually measuring the same thing. They are more or less identical. Now, it is important to note that these are just guidelines, and the interpretation of strength of a correlation coefficient may vary depending on specific context and research question. Now, obviously, these are general guidelines, and different scholars, statistics experts, or statisticians have recommended different guidelines. Now, you may refer to different, obviously, text that is available maybe on books.google.com or in your own library to see what other viewpoints are there. Now, how do we interpret it? Let's look at an example. Now, I'm going to test it, the relationship between these two variables. How to do this? Let's do it in SPSS. So go to Analyze, Correlate, Bivariate. Now, I have already created a single composite variable of vision and organizational performance. How did I do it? Well, I did it in the previous session as well. So what you need to do is just simply transform it or compute a single variable by taking the mean of these 4 variables, and similarly for OP as well. So let's put in vision here, OP here, Pearson, all good. Just simply press OK. Now here is the correlation. The correlation between vision and OP is 0.622. So what about this? What is this? Now this here is the correlation between vision and vision. Obviously this is bound to be 1 because both are identical. The correlation between vision and OP is positive because there is no sign here. Now, is it significant? Yes, it is significant. Why is it significant? Because the p-value is less than 0.05. Now, my interest when we are assessing relationship between variables is to assess the strength. But before strength, I also want to assess the significance of relationship. Now, in this case, the relationship is significant because the p-value is less than 0.05. And that's the general rule in social sciences research or general research. When we are assessing the significance of relationship, the p-value that is taken into account is 0.05. So if the p-value is less than 0.05, you will say your hypothesis is accepted. That is your alternate hypothesis. That is, you reject your null hypothesis. This is your sample size. Now again, this is just mere repetition. First it was vision with vision and OP. Now it's OP with vision and OP. Now how do you want to present it? You can just simply remove this particular section here or this particular section here when you are presenting your results in a Word document. I'll just show you how to do this as well. Now the correlation coefficient is 0.622. And what do we mean by this? Let's have a look. So it falls here. So this means there is a strong relationship according to this criteria. Now the R value between vision and organizational performance is 0.622. The R value is positive, that is, it is greater than 0, which means that the relationship between vision and organizational performance is positive. We can see that this in the scatter plot as well. So how did we do the scatter plots? Let's quickly go back and do it. Just go to analyze, graphs, legacy dialogues, scatter plot. Let's do a simple one. Now let's add vision to x-axis, OP to y-axis and press OK. And here you see the direction of the dots, the increase in vision, and then there is an increase in OP as well. You see the tendency is right here. Now if you see here, look at this. There is this tendency here. The scores are clubbed here, joined here at the top right. With an increase in vision, there is an increase in organizational performance. Moving on. Now, in the context of the data, the positive correlation confirms that the understanding and clear communication of the company's vision can help improve organizational performance, because if you are increasing the vision, the understanding of the vision, the acceptability of the vision, the performance is increasing. Now, there are different properties of correlation coefficient. Now, the correlation coefficient do not change with the change in the unit of measurement. In other words, if we change the unit of measurement for an explanatory variable, that is your predictor, the outcome variable will have no effect. That is, there is no effect on the R, that is your correlation coefficient. The correlation measures only the strength of linear relationships between two variables. It ignores any other type of relationship, no matter how strong it is. So the objective of correlation coefficient is to measure the strength. The higher the correlation coefficient, the higher the strength. The correlation by itself is not enough to determine whether the relationship is linear or not. Now, to see this, we will have to look at R square along with the scatter plot. Now, the variables may have strong relationship. The correlation does not tell us whether the relationship is linear. We will have to see the scatter plot, and in this case, this is my scatter plot. So double click on it, go to elements, fit line total, And as we did in the last session as well, these dots here shall be closer to this line here. The more they are closer to this line, the more we can accept that there is a linear relationship between the two. In this case, we can say to a certain extent it is a linear relationship. Now, how do we further, how do we report the correlation? Now, a Pearson correlation was calculated to examine the relationship between the variables. The correlation coefficient was, now what is this n? This is 341. That is your sample size. And the correlation coefficient was 0.622. P-value obviously less than 0.001. And this indicates a strong positive relationship between, let's say instead of variables, we write vision and organizational performance. Now this example is good enough when you've got only two variables. So this is how you write your hypothesis or present your correlation results when you've got two variables. Now what if you've got more than two variables and you need a correlation matrix? So how do you get a correlation matrix? Now let's remove this. Go to Analyze, Correlate, Bivariate. You do not need to do anything else, just add the third variable here. And this will give you a correlation matrix. Now you can use one-tailed if you know that the possibility of the relationship is positive or negative. Now based on literature review, you know that okay, this relationship is presumed to be positive. Now you are expecting the relationship to be positive or negative, you can use one-tailed. Now if you're not sure whether the relationship would be positive or negative, you can use two-tailed. In this case, let's use one-tailed, press OK. Now here is your correlation matrix. Let's use it. Let's format it in Word document. Now first thing, right click here, auto fit to window, add your borders. Now let's say table 1 correlation matrix. Now I do not need this cell here, remove it. And I just need correlations. So what I'll do is go to table layout and put it in one cell here, the variable or the construct names. Now they are done. Now I do not need the significance and n. Let's remove it. Now this one, remove it, put it outside your table and write a note. Remove this cell. Now there is a repetition. Normally what we do is we remove the values above the diagonal. And layout. Now remove this as well. Right, select it, right click and delete. Now again click here, auto fit to window. Now obviously just select these three cells with the data, home, center. Now finally click here, and home, let's say no border, then bottom border, top border, and then bottom border here. Now describe your correlation coefficients. How to do this? I've got an example here. Copy, paste it here. A Pearson correlation matrix was calculated to examine the relationship between variables. Now, which are your variables? Let's put them here. That is vision, VIS, comma, organizational performance. You may change the order, comma, development. The matrix presented in table 1, that there was a strong positive relationship or correlation between, let's say, vision and organizational performance. So R was, let's say the sample size was this, R is 622 and the p-value was less than 0.001, which we can see in the original matrix here. Now there was a moderate. Now again it was a strong, but if it was moderate we could write moderate, and again this was positive. So if this would have been negative, we would have mentioned negative correlation between development and organizational performance. Again R 3341. Now obviously you might have 10-15 variables, so you do not just describe the relationship of each variable with the other variable. What you need to do is you simply report those relationships that are significant or important. For the rest of them, you can mention no other significant correlations were found. That's it. So this is how you perform correlation in SPSS. How to perform correlation analysis with confidence interval. For this, I'm going to use SPSS 29 version. I'm going to calculate the correlation between vision, development, and organizational performance. To do so, I'm going to go to Analyze, Correlate, Bivariate with confidence intervals. Now I want the correlation between these three variables. Now you can do it, that is, you can do the correlation of vision with development and OP, but then there will be some missing output as you won't have the correlation between development and organizational performance. For example, if you press OK here, now it is running bootstrapping. Now there is no correlation between development and OP in the results. So let's go back, go to Analyze, Correlate, Bivariate, and I'm just going to put these back up here. Or in order to avoid repetition, I'm just going to have 2 here and 1 here. And I'm going to use bootstrapping technique. For now, I'm just going to go with the default values. Now what I do is I'll press OK and it will run the bootstrapping for 1000 samples. Normally the recommended is between 5000 to 10,000. Now if you look here are my results. The correlation between vision and organizational performance, the Pearson correlation is 0.619. The significance is less than 0.001. This means that the relationship between vision and organizational performance is significant. Now the next thing that I'm interested in, this is your sample size, I'm interested in the confidence interval. The lower level and the upper level. The relationship between development and organizational performance is also significant. The 2 asterisks, and they are significant at 0.01 level. The sample size and the 95 confidence interval, the lower level and the upper level. Now what do we mean by this confidence interval? Let's understand this. Understanding confidence interval. A confidence interval is a range of values that is likely to contain the true value of population parameter. Now, since we cannot study the population, we have confidence interval to provide us with the true value of the population parameter, such as the mean or proportion. Now, the upper and the lower bounds of the interval are called the upper level confidence interval and the lower level confidence interval, as we saw in the output earlier. Now they provide a range within which the true value is likely to fall. So the true value of the correlation is likely to fall between this lower and upper confidence interval. the true value for the correlation between development and OP is likely to fall between 0.644 and 0.784. Now, in simpler terms, it is range of values that we are certain that the true value falls within based on the data we have, that is our sample. Now, the true value of the population parameter is the actual value of the characteristic of the entire population from which the sample is drawn. For example, if we wanted to know the average height of all adult humans, the true value of the population parameter would be the actual height of all adult humans. But the problem is we cannot measure the true value of population parameter directly, as it would be infeasible. So instead, we use our sample to calculate the true value of the population parameter through confidence intervals. Now, for example, in this case, if the lower level confidence interval for the correlation between the two variables is this, and the upper level is this, as we see here, 0.528 and 0.701, for the correlation between vision and organizational performance, this means that the higher or high level of confidence, usually denoted by the percentage 95%, that the true population correlation will fall between 0.528 and 701, and we are 95% confident that this will happen. That the correlation between vision and organizational performance will fall between 0.528 and 0.701 for the population. The correlation coefficient is a measure of association, and its values ranges between -1 to 1, where minus sign indicates the negative relationship and no sign or the positive sign will show the positive relationship. Now in this case, it is moderately positive. So this is how you can interpret the confidence interval when you are running the correlation analysis. How to find differences in correlation between two groups. Let's say I've got this data here, and let's do some normal correlation. Correlate, bivariate, and let's say I assess the correlation between organizational commitment and collaborative culture. Press OK, and here are my results. Now I want to find out whether this organizational commitment and collaborative culture differs between two groups, let's say male and female. Now if you want to further understand the concept of correlation and interpretation of basic correlation analysis, you can watch the video in the description. In this case, it is 0.608, so we can say it's a moderate correlation. Is it significant? Yes, it is significant. Now, how to do this? Let's go to Data, Split File, and I want to compare groups by gender. Press OK, and now go to Analyze, Correlate, Bivariate, and I've already got the variables here. Press OK. Now for male, the correlation is 0.603 between OC and CC, and for female, it is 0.624. So the correlation of OC with CC differs slightly as it looks between male and female. It's higher in female as compared to male. But is this difference significant? So the difference of correlation, whether or not it is significant, we can check it using a correlation calculator that will give us the difference and whether that difference is significant or not. Now to do so, what I will do is I will use the Daniel Super Calculator. Now here is my correlation calculator, significance of difference between two correlation, and this is the calculator. So the correlation coefficient for the group 1, that is male, let's say it was, so for male it was 0.603 and 0.624 for female. 603, and for female it was 624. And what was the sample size? Let's look at the sample size. 288 and 52. 288 and 52. Let's calculate. Now here is the Z score, and here is your probability value. Now here this is greater than 0.05. So we can easily say that the difference is insignificant. The difference of correlation between male and female is insignificant. So the relationship of OC with CC is the same as in male and in female.